who is a data scientist at Ascent. Today, she will give a lecture on predictability check, demand forecasting. Hilary, the stage is yours.
Thank you. So welcome from my side as well. I prepared a short introduction via PowerPoint, and then we'll switch to the tutorial part in Python. So I will share my screen. Hope you see my screen. Yeah, okay. So let me start by introducing myself. So my name is Hilary, and I'm a data scientist at Essen, based in Austria. I hold a degree in biomedical engineering, and over the years, I've gained extensive experience in data processing and analytics. My work has spanned various industries, but I have particular focus on healthcare, pharmaceutical, and also the food industry sector. So where I've been involved in leveraging data science to solve complex challenges. So one of the key elements of my projects is ensuring seamless integration of data-driven solutions into the existing IT system landscape of different clients. As mentioned, I work at Ascent. We were focused on 3 core areas there. So basically data and AI strategy. This involves working with teams to generate use cases and ensure alignment with the business strategy. Secondly, we have data science. So we focus on building models based on structured data, generating insights and improving decision-making through exploratory data analysis. And then lastly, we have AI. We apply advanced AI techniques to unstructured data, including text, images, and video, using state-of-the-art approaches like transformers for tasks in NLP and also computer vision. So I'm excited to share my insights today as we will dive into the topic of demand forecasting and predictability checks. So let me walk you through what we'll be covering today in this guide to building a demand forecasting model using Python. Our primary focus will be leveraging advanced machine learning techniques, especially XGBoost, to predict future demand with high accuracy. So first, I'll introduce the key concepts of demand forecasting. Then we'll explore the predictability of time series data. And we'll look into time series analysis and how to use historical data to identify trends and also patterns. After that, we'll discuss model selection, focusing on why XGBoost is an effective choice. Then we'll move to feature engineering, refining the data to ensure optimal performances of a model. And I'll also walk you through some case studies to illustrate these concepts in a practical setting. And then finally, we'll cover the practical implementation steps, including data preprocessing, using pandas, model training with XGBoost, prediction of the future demand, and also creating an interactive and user-friendly web application using Streamlit to visualize and interact with the results. So by the end of this tutorial, you should have the skills to implement your own demand forecasting model tailored to your specific use cases. So let's now explore why accurate and automated demand forecasting is so crucial for businesses today. Firstly, to increase revenue. So with precise forecasts, businesses can ensure they meet customer demand effectively, avoiding missed sales opportunities. Also, a big topic is the reduction of waste. So accurate demand forecastings help to reduce the overproduction, ensuring that resources aren't wasted by producing more than what is needed. Then we have also demand predictions have to get like a set dynamic prices. So it allows businesses to adjust prices dynamically, which can either boost revenue or help minimize waste by controlling production and also the sales rates. One of the greatest advantages of modern demand forecasting is also automation. So advanced algorithms can quickly create forecasts for thousands of locations and also products in seconds without the need for human expertise. And then lastly, we have improved planning. So every business process that depends on forecasts will be enhanced, from inventory management to marketing and supply chain operations. So more accurate predictions lead to better, more precise planning. To summarize the up, accurate demand forecasting drives, firstly, efficiency, reduces the costs, and also boosts the business performances across the various sectors. Now let's address a key question in demand forecasting. Is my time series data even predictable? So before diving into building a model, it's crucial to understand the predictability of the data. Time series data that exhibits clear patterns, such as like trends or seasonality, tends to be more predictable. If your data is like consistent and shows reliable historical patterns, you have a strong foundation for accurate forecasting. However, we also need to consider external factors like sudden market changes, unexpected events, or maybe noisy data that may introduce variability and also reduce the predictability. So in this part, we'll explore how to assess whether your time series data is suitable for your forecasting and what factors can enhance or hinder its predictability. Now that we've introduced the concept of predictability, let's dive deeper into what makes the data really predictable. The goal of the predictability is to determine whether future states of a variable can be derived from its current or historical data. So if the data has high predictability, this means that the future outcomes can be forecasted with a high degree of accuracy using statistical or machine learning models. So there are like 4 key factors that influence the predictability of time series data. First of all, we have scope of the data. So larger data sets provide more comprehensive insights, enabling the model to detect more patterns and also trends. So this generally improves the accuracy and reliability of the forecasts. Also, quality of the data, so clean, well-structured, and relevant data is crucial for any predictive analysis. So poor quality data can lead to inaccurate predictions regardless of the model. Then we have also historical consistency, so data that demonstrates consistent patterns tends to often be better at predictability. So if your data shows repeating trends or behaviors over time, the forecasting becomes much easier. And then we have like external factors as well. These are just like influences such as like market fluctuations, economic changes, or unforeseen events that can just like introduce noise or variability. So that can like really reduce the predictability of the data. And by keeping those factors in mind, we can assess the predictability of a data set and make informed decision about which models and also which techniques to apply. Let's now discuss the steps involved in determining if your data can be used for AI-supported forecast. First of all, we have like a use case definition, and also we need to know we have like the data for it. So the first step is defining a clear use case for your AI-supported forecast. This involves understanding the business problem you want to solve and ensuring you have the right data available for that analysis. Second of all, we have the data transformation for the first AI model. So once we have a use case and the data, the next step is transforming the raw data into a format that can be used by AI models. This involves cleaning, pre-processing, feature engineering to make the data just like really ready for analysis. Then we have like the first model implementation and also validation of influencing factors. So after the data was transformed, we implement our first AI model. So at this stage, we validate which factors or features most influence the outcome, helping refine the model for better accuracy. And after that, we have like the last step, which is mostly like a review meeting to discuss results and derive next steps. So we always try to make like a simple model and then to check, okay, what could be like other features that we could like implement to improve the model and to get like better results as well. So by following this structured approach, we can ensure that data is well prepared and that the AI model is aligned with also the business goals and the use case for accurate and also for the forecasting. I have like two examples for real world case studies, both from the food industry. First of all, we have like Shankal. It's a startup that delivers a variety of foods to fridges in office locations. So their business model relies heavily on precise demand forecasts to meet employee demand at each location, while also minimizing food waste. So each fridge has different consumption patterns, delivery schedules, and product requirements, which makes standard solutions unsuitable. Previously, this planning process was managed manually by experienced employees, but this approach was like a lot of time consuming and also prone to errors. So to solve this, Shrankle needed an optimization algorithm that could combine demand forecasting with food waste reduction, providing a more automated and efficient approach for planning. So the key facts that happen here was like gathering the relevant historical and also current data, cleaning and preparing the data to train then the model, also like to implement a pipeline that can forecast the demand accuracy, and then also like post-processing. So refining the model's output to align with the business goals. So this project kind of like showcases how demand forecasting can address complex business challenges in industries where accurate predictions are crucial for both operational efficiency and also sustainability. Another great example is another client, which also is an example of demand forecasting in the food industry. And the client's production planning relied heavily on expert forecasts provided by experienced employees. While this approach worked, it was subjective and not scalable as the businesses grew because the client needed a more data-driven approach to ensure accurate production predictions for each product. So using, again, historical data, we trained a machine learning model for each product, and these models predicted future demand and can be seamlessly integrated into their existing production planning software, automating much of the forecasting process. So now let's discuss the benefits that can be achieved through precise demand forecasting and how the implementation of the machine learning models. So firstly, we have like more precise demand forecasts, or accurate forecasting improves the production planning. This leads to considerable operational benefits by ensuring that businesses are prepared to meet demand without overproduction or underproduction. Then also the reduced cost and increased efficiency. So with better forecasts, companies can optimize their resources, reducing unnecessary costs. And then we also have optimization of forecasting accuracy and resource utilization. So machine learning plays a crucial role here. It allows businesses to leverage advanced models that provide high accurate predictions, and these models optimize resources, making the entire production and supply chain more efficient. So now I will like get more to the tutorial part of the session, where I'll guide you step by step through the process of developing a robust demand forecasting model. In this part of the presentation, I will explore also the key elements of building a model, dive into the data preprocessing and feature engineering, working with the XGBoost model, and then we'll visualize that in Streamlit. So let's kind of like dive into time series analysis, a key step in building an accurate demand forecasting model. I have some slides left where I would just like explain what we'll be doing later on in the Python notebook, just to get like a little bit of an overview what will happen, because it's easier to just explain with a presentation here. So in this process, we will analyze historical data to identify patterns, trends, and any seasonal fluctuation that may exist. And these findings are then used to generate the forecast by understanding the underlying behavior of the data over time. For example, I have here some sales data displayed, which provides the customer a product ID, and also the quantity of what was sold. Then we have the date. We also have a price of that product. And also we know if there was like a campaign going on at that day or not. So that's basically the sales data we're going to work with. So we have like a lot of customers, a lot of different products, and each customer has like is like selling some of those products. One of the critical steps in improving the accuracy of the demand forecasting models is the feature importance analysis. So this process helps us to focus on the most influential factors leading to better predictions. So let's kind of like break this down into 3 key objectives. First, we have the identification of the most influential features. So by identifying which variables have the most significant impact on the model's accuracy, we can ensure a forecast are based on the most relevant data. Reduction of model complexity is the second thing. So simplifying the model by removing irrelevant features reduces the complexity and makes the model more efficient without sacrificing accuracy. And then we also have like the improvement of the model interpretability. A less complex model is easier to understand and also to interpret, which is especially valuable when presenting the model's outcomes to stakeholders or business partners or whatever. So in this feature importance analysis, we typically focus on 4 kind of data types. We have historical data. It's recognizing trends and patterns from past sales using methods like moving averages or growth rates. We can also use like weather data, so maybe temperature or other weather variables to just take into account for the weather-dependent sales fluctuations. Also, we have marketing campaigns, so assessing the impact of also promotions and campaigns on sales is better to improve like the prediction accuracy. And then we also have like macroeconomic indicators, so using GDP, unemployment rates, and other economic indicators to capture the broader market conditions that can influence the demand. So let's move on to the crucial steps of the preprocessing and the feature engineering on our sales data. So these are the foundational tasks that ensure our data is clean and probably formatted for the model to perform well. So yeah, let's just break it down on some key steps that we'll be doing then in the tutorial. So the first step is to handle missing values. It's important to document all steps taken to fill or impute missing data and ensure that no critical information is lost. This helps maintain the integrity of the data set. Yeah, and then secondly, we have date-related features. So not only the date information can be an important source of insight, but also we can extract from them features such as the day of the week or the week number, also the month and the year. So these features help capture the seasonal or also like cyclical patterns in our sales data. Then we also have like shifts. So shifting the past sales data is essential for understanding trends in a time series. So we shift data forward or backward to create features that capture those historical sales performances and can also better predict future values. We will be using the shift trend. So shift trend refers to the shifted version of the trend component of the time series data. So the trend represents the long-term upward or downward movement in the data. So sales increasing or decreasing over time. And this component is extracted using time series decomposition. So example, if we shift the trend by 7 days, we are using the trend from 1 week ago as a feature from the current observation. So this helps capture the influence of the long-term changes in the past or present value. Also, we have seasonal shift. So that refers to the shifted version of the seasonal component of a time series data. The seasonal component captures rapidly cycling patterns in the data. So higher sales every weekend or during certain times of the year. So for example, when we have like a shift seasonal 7 that brings the seasonal value from 1 week ago into the current observation. Also, we have the different shift, which is like between the observations in the time series with an added shift. So differencing is a common technique to remove trends or seasonality from the data by calculating the change between values. So sales on day 2 minus sales on day 1. So this kind of like helps stabilize the time series and make it stationary. So for instance, shift difference 7 captures how the sales value has changed compared to 7 days ago. So we also have like the feature like windows. So we also compute rolling statistics such as mean, the minimum, the maximum, and also the standard deviation. So this allows us to smooth out the data and better capture the trends by observing data in a rolling window of time. So for a data set with daily sales data, a 7-day rolling window would compute the statistics for each 7-day period, moving 1 day forward at a time. So that's why rolling. we're having like window minimum, maximum. So example, for 7-day rolling window on sales data, window max 7 would give you the highest sales value within each 7-day window. And that's the same with the minimum, just like it would give like the lowest sales value within each 7-day window. And then lastly, we'll also have the holidays. So holidays often have a significant impact on demand. So therefore we define specific features for holidays, including whether sale occurred before there was like a holiday, during, or maybe after holiday. So this helps in adjusting forecasts based on holiday effects. Then it's not going forward. So then we will like move forward to the model training. So for training our demand forecasting model, we will be using XGBoost. That's a powerful machine learning algorithm known for its accuracy and performance. So here are the steps involved in training the model. We will have like a label encoding. We first label encode the category of features in a data set to convert them into numerical values that the model can understand. We will also like split the data into training and testing set. The training set is then used to teach the model, while the testing set is used to evaluate its performance. Then we will train the model using specified hyperparameters. And then we will also like display the feature importance, so we know which are the most significant influences on the model's prediction. Once the model is trained, we evaluate its performance using the root mean squared error. It's a commonly used metric for regression models that measures the average magnitude of error between the predicted and actual values. In our case, we apply to assess the accuracy of our predicted sales data. And finally, we then are going to look at the results in a Streamlit dashboard, which is just like a user-friendly way to display the data in a Python framework. So now I will be really switching to Python. Let me just switch. Wait, it's not working. I think you should see my screen. So, as already described in the presentation, this notebook demonstrates how to perform demand forecasting by leveraging the machine learning techniques. So we will like go through the preprocessing, then building the model, and then evaluating it. So in this section, I'm just doing some imports of libraries we are going to need, and also I am importing some helper classes like the model trainer, and also a data preprocessing class, which I wrote before that. Just as mentioned before, here's like the data preprocessing class. I implemented before all the things I just like explained, like the rolling mean, the holidays feature, the rolling sum, max, min, also the shifting, before holidays, the missing days. So everything that comes to the feature engineering is in that pipeline. But since it's like a lot, I won't present that because it's like straightforward. So that what happens in that data preprocessing. And then I also have like a model trainer. I will explain that later on. So as mentioned before, we are working with the sales data, which we need to clean and prepare for before we can train the model. So this cells basically just loads the data and visualize it again, like the first kind of rows. As mentioned before, we have a customer, or we have a lot of customers. We have a lot of different products with the quantity that was sold on that date with a specific price. And also we know if it was a campaign or not. To gain some insights into customer behavior, we will calculate how many times each product was purchased by each customer. So this information will help us to identify the most frequent product-customer combination. So here we can see that these two would be with the highest one. On the other hand, we also investigate the customer product combination with the highest quantity sold. So instead of just counting the occurrences of a product customer combination, it looks at the quantity column and sums that one up. And yeah, so we know how much of each product was sold to each customer. So we got here, I'm like printing highest combination customer and also how much was sold, just to get like a little bit of a feeling for that. And to visualize for that highest combination, I have made with Plotly a time series plot with the x-axis, the day, and also the quantity sold on the y-axis. So this bar is just the time series graph showing the sales trend of the highest product for the particular customer over the period from September 2022 to March 2024. So the y-axis is the quantity sold, which ranges from 0 to 50. So each data point represents the quantity of the specified product purchased by the customer at a given time. There kind of like seems to be a lot of variability, with quantities generally fluctuating between 10 and 40, though occasionally peaks may go slightly above 40. So the plot does not seem to show any obvious long-term trends, so it's not like going upward or downward, but the sales quantities seem to fluctuate frequently over short intervals, potentially indicating regular purchase patterns. So there are occasional peaks, particularly noticeable around May 2023, and also November 2023, where sales quantities spike more significantly. So the sales appear to occur consistent throughout the period without any long gaps, indicating a steady demand for the product by this customer over the 2-year period. To go to the next step, which would be like pre-processing, I kind of like spend a lot of time in the presentation on that one, just to really get the feeling for you, okay, what is happening in a pre-processing pipeline and the feature engineering. So as mentioned before, I have that in the data pre-processing implemented, and I just run the pipeline with a rolling or shift with 7 days, and also like define the date column, which is like date here and sales column quantity here. Yeah. The next step is to show you this pre-processed sales data. I'm just going to open it up here. So we have the dates, the customer, the product ID, the quantities, and the price, which were like the data frame we used originally, and also the campaign. And now we got like the features I created in that data frame with the year, the day of the week, the month, the week number, also like the holiday, was on that day like a public holiday or not. Then also which day it is in the month. Then if it was like before holiday, that means it's the week. from that day. Was there like a holiday before that or after that? Because that's also like kind of important. Then we have like the windows I mentioned for rolling window for 7, 14, 21, also with the min, also with the max and the standard deviation. And then we have all the shifts going on with 7, 8, 14, 15. You can choose them however you think it's like necessary, also with the seasonal shift and the trended shift. So yeah, that are basically what happens in our feature and preprocessing pipeline. We will need those to train an XGBoost model for the sales forecasting. So the next step, as already mentioned, is to train the model. First, I have a short little function here called label encoder. So that uses the label encoder from sklearn, which converts categorical data into numerical data that can be used by the XGBoost model. I'm using that one later on in another one. I created here a function named train models that trains a model and evaluates its performance. So a quick breakdown of what happens here. The input is a data frame containing the data to be used for training and testing, so our preprocessed data set. Then the date column and also the sales column, and a Boolean indicating whether to show the plots during the training process or not. The function creates an instance of the model trainer class and loads the data into it. So as mentioned before, I wrote the model trainer class before that. Just to go through it real quick, we have the model trainer. We have a function there to load data. Also, I have a function to plot the importance with plotly. So the feature importance, I will show you that plot later on. Also, I wrote a function to split the data into a training, task set, and also, if needed, a validation set. Then we have just the train model, and also the train and predict function as well. So I go back to this one. I just call that class here, load the data, also set my date and my sales column, and then I define my training and testing periods. So the function splits the data into a training and a test set. The training period includes all data up to 28 dates before the latest date in the data set, while the testing period covers the final 28 dates. After I have that defined, I just print that out, so I know it for each run which things I have set. And after that, I'm going to the splitting data, which is in my model train class. This one just splits the data. And then next thing, we have the label encoder I already mentioned. So this function identifies category columns in the training data and applies the label encoding to them. This transforms the non-numeric data, like, product name, into the numerical ones. Then also we come to the hyperparameters. It is which need to be defined for a model. These ones include the random C for reproducibility, so the random state. Also the model complexity parameters like max def and the N estimators and learning rate, and also regularization parameters to prevent overfitting. Then the model is trained using the training data, and the predictions are made on the test data. So the model is also evaluated on the test set using measures like R-squared and root mean squared error. So the train and predict method here, it returns the test data. and also the trained data, and also the R2 or the root mean squared error results for that one. The whole function itself, like that's the train models one, that returns test data with the actual and predicted values, allowing you to compare how well the model performed, and also the RMSE results data frame. That's just the data frame summarizing the model's performance on the test set. So after that brief description of the function, we will now use it and train the model. So this kind of like code snippet is working with the preprocessed sales data to train the model and evaluate then its performance for multiple customer product combinations. So we have here like the different combinations. We also like drop the duplicates as well. And then we put everything in our train models function. After that, we just printed the start and of train and test. And then we can also see the scores. So the R-squared score is around 60. It shows that a model is moderately effective, explaining about 60% of the variance in the sales data. And the root mean squared error of 1.25 indicates that on average, the model's predictions are reasonably close to the actual value, with an error of about 1.25 units of sales, which is pretty good in that one. So these matrices suggest that the model has learned meaningful patterns in the data, which could likely be improved further with like tuning, additional features, or more sophisticated models. So as we can also see in the feature importance plot, that just gives like which features are like most important and which not. So the x-axis contains the name of the features used in a model, and these features are ranked by their importance. So with the most important features on the left and the not so important on the right. So our top features would be product ID. This feature has the highest importance score, meaning the product being purchased is the most critical factor in predicting sales. Secondly, we have the window 40. So this feature is like the rolling window we mentioned before. It could represent, it represents the 14-day rolling average, and it's really like in the high importance of that one. Also like the campaigns, if like a customer or a shop or whatever is like having a marketing or promotional campaign, plays a significant role in the model and also in the sales prediction. And also we mentioned the window 14, but also like window min 14 represents just like a really important feature. I would categorize features like customer, price, day of week, also contributing moderately to the predictions. So I would like give it a mid-range feature. This suggests that both customer demographics, pricing and strategies, and weekly patterns affect sales behavior. And also we have window some 21 and some 14, which represent longer rolling window statistics, which try to capture the longer term trends in sale. I would get that as well, like a mid-range feature. And then we also can see that we have some features that are just like not really important at all. And also some of them that are just like less important features. Also, we can say that after holidays is not that important. And also the before holidays, it matters if it was before and not that much if it was like after. So that is also really important to see. So after testing multiple customer product combination, stored in the test data list, which is up there. The code concentrates all the test results into one data frame, full test data. It then calculates the root mean squared error across all predictions to evaluate the overall accuracy of the model on the test set. So the root mean squared error is calculated by comparing the actual sales with the predicted sales, so the quantity with the Y prediction. Mean squared error computes then the average of the squared differences between the actual and predicted values. As we can see, we have here a value of 1.28 as already described above. That's a really good value because it's just like 1.28 quantities next to it. So next thing would be to visualize the results of that. So to just look deeper on how does the test set and everything looks like visually. So on that note, I will share my Streamlit dashboard. Put it up. So here I made a Streamlit dashboard. I hope you can see it. Yeah, I think it's fun. So what is Streamlit? Streamlit is an open source Python library that enables you to create interactive web applications for data science and machine learning projects with minimal effort. So it allows you to transform data scripts into shareable web apps in just a few lines of code without requiring any knowledge of web development frameworks like Flask or Django or whatever. So you can see here a really simple Streamlit dashboard. So at the top of the page, there are two drop-down menus. First of all, we have select product. So I can just like scroll through all the products we have and just choose one. The same thing is the select customer. So I have different customers and then the products to that. And below the drop-downs, we have then the time series plot that compares the predicted values to training data. So the red line shows the model's predictions for the selected product and customer, and the gray line shows the actual training data points. So the x-axis represents the date, ranging from December to late February. I just choose to do it like from December because I have like 2 years of data and that would be like a lot to visualize here. And the y-axis represents the quantity sold. Each dot represents the actual sales quantity for a given day, while the lines indicate the trends over the time. So basically, this chart helps to visualize how well the model is predicting future sales for the selected product and also customer. And the model's prediction, which is in red, seems to follow a similar pattern to the actual sales, but there are like some discrepancies. Also, like in the Streamlit dashboard, I just printed out some performance matrices for the selected customer. So you get for each customer you select in the drop-down, the root mean squared error, also the mean absolute error, and also the R-squared value. So just like looking and playing around in the Streamlit dashboard, we can see that when we choose here another product, the plot changes, obviously. To say here, the prediction generally captures the overall trend and fluctuations of the actual sales, though there are discrepancies. For example, we have like peaks in the actual data, like here, and that are just like missed by the model. because as we can see here, we have like a lot of 0 points here, then we have a peak as well here. So it's not always easy for the model to capture the behavior. Maybe by just like choosing another one, we can also say here, the predicted values generally follow the pattern of the actual sales data, especially in February. However, the model underestimates, again, the extreme peaks seen in the training data, such as the sharp spike, like around December here, and smooths out the fluctuation seen in mid-February. So we can also see here always the root mean square error for that combination. So we have here like 2.17. Also to mention is that as we can see here, we have like a lot of different products. So this range is going from 1 to 10. But if we like select another one, which is like just going from 1 to 2, it's really hard for the model to capture that behavior, because it's just like always 0 and then goes up to 2 or 1. So that is like kind of hard to get from the model to capture these behaviors. But yeah, so we can really like play around with that and just see, okay, how does it look like? What is the quantity? We also have some plots with the quantities that just go up to 50 or 40, as shown in the Python script earlier on. So we can really like look into the data and also see, okay, which products behaves which ways. And to also mention here, it would be like possible to just like tune the model further, because we just used like the basic of the features, and also maybe it would be important to get like more features into it. So also about like the customer, maybe some customers have a correlation, maybe some products have a correlation. So that is really to kind of keep that in mind as well. I will switch back. To my PowerPoint, because I want to make like a big conclusion on that one. So basically what we did was to implement a basic model using some kind of like features that are like easy to implement. The model can provide good to very good prediction on certain products, but not on all. Because some products just don't have really a pattern in the sales, or are just like sold on some kind of seasons, like maybe just 1 month and then not sold anymore. So that is also kind of hard. But what is great on XGBoost, we have it offers like a big flexibility. So one of the major advantages of this approach is you can easily integrate additional products and customers into the model with minimal effort, ensuring scalability. So also you could say you're just like taking into the model the products that have like sales over 10 or over 5. So it makes sense to make a prediction, because if you just like sell one product on one day, just like one product, it's also like hard for a model to predict that one. Also, an model is capable of predicting an unlimited number of product and customer combinations. So as long as sufficient data is available, this means it can handle the complexity of large-scale forecasting. So that is really also a big plus on that one. So you can have like each product and customer combination you wish for. But the model can be like continuously redefined by integrating additional influencing factors. So maybe things like promotion. So where was the campaign? Was the campaign at the customer or in the shop where was it placed, where was the product placed, how much space is there to place that product as well. So maybe we could think about meters, how much space is there? Is the product like in a higher shell in a shop, or is it like more down there? So that's also like a thing to where the model could improve. And also with maybe weather patterns. So some products might get, I don't know, might be better when the weather is good, or when it's like bad, or when the temperature. So we also have to think about that as well. And also when thinking about maybe grocery stores, if that was like the customer, then you also have to kind of like think the population data. So maybe I can, like the model could be influenced by how many people live at that city where the store is. So that could all improve the quality of the forecasts, making the model even more accurate over the time. I think it's always like a work in progress, but to get like a really simple one, the predictions are pretty good for some products. So yeah, in conclusio, this demand forecasting model provides a scalable, flexible, and also highly accurate solution to meet the forecasting needs of a wide variety of businesses. I hope that I could give you like a great quick introduction to everything. If you want to go with me through the code step by step more, I would just go like back to questions, and we can use the rest of the time to walk through the code more specifically, or you have any other questions about demand forecasting, then just let me know. So there was a question if the code is shared on GitHub. No, it's not yet. But I will be sharing it soon, because there's like still some stuff missing. So I will be do that one, yes. Any other questions?
So I'm just hopping in to see if you saw the first question, right? Yeah.
Yeah, I already
Answered that.
one.
Okay.
Yes.
If anybody would like to ask their question in person, they can raise their hand, and I'll just enable your mic.
And also is if anyone like wants to get, because the question was if it's shared like on GitHub, just like reach out to me via LinkedIn, and then I can send you also like the link to the GitHub as well.
Okay. So I guess we can go like going once, going twice, if you would like to ask any more questions. If I'll assume that is a no. So just thank you, Hillary, for a great lecture, and we can end this meet.
Thank you.
Okay. Goodbye to everyone, and enjoy your next lecture.